here's something wild that nobody's really talking about. Every time you ask ChatGPT a question, every time you generate an image with AI, every time you use any of these smart tools, you're basically turning on a small power plant. Not literally, but the electricity these things consume, it's insane. And right now, in December 2025, we're hitting a wall that could stop the entire AI revolution in its tracks. It's not about computing power. We have the chips. It's not about data. We have mountains of it. The problem is way more basic than that. We're running out of electricity. And tech companies are so desperate to solve it, they're doing something that sounds absolutely crazy. Building their own nuclear reactors. Not massive power plants, tiny ones, small enough to fit in shipping containers. Reactors you can literally truck to a site and plug in. This is the story of how the AI boom might force us to completely rethink nuclear power. Let's break it down. The monster that never sleeps. Let me put this in perspective. You know how your laptop battery dies after a few hours? Imagine a computer that never turns off, never sleeps, never stops thinking. That's basically what AI data centers are. And they're absolutely devouring electricity at a scale most people can't even comprehend. Training one big AI model, like the kind that powers ChatGPT or generates those realistic images, uses as much power as 120 homes in an entire year. But here's where it gets crazy. That's just to build the model. Once it's running and people are using it, the power consumption never stops. ChatGPT alone uses roughly 564 megawatt hours every single day, just answering questions. Now multiply that by all the AI services launching every month. Right now, data centers consume about 4.4% of all electricity in America. That's already massive. But experts say by 2028, that could jump to 12%. By 2030, could be double or triple that as AI explodes. To put that in perspective, we need to build the equivalent of 19 massive nuclear power plants in the next few years just to keep up. And here's the kicker. The power grid can't handle it. You can't just snap your fingers and build new power lines. These things take decades to approve and construct. So tech companies are looking at this problem and basically saying, forget waiting for the grid. We'll just build our own power plants. Why the obvious solutions didn't work. You're probably thinking, just build more solar panels and wind turbines. Problem solved. If only it were that simple. Solar panels are great when the sun's shining. The second it gets dark, zero power. Cloudy day, power drops like a rock. Wind turbines? Same story. When the wind stops, they're basically giant, expensive statues. Batteries can help, sure, but we're talking about data centers that need constant, massive amounts of power. Current battery technology just can't store enough to run these facilities through the night. So what's the fallback? Burning fossil fuels. Natural gas plants can run 24/7. They're reliable. They're already built and connected to the grid. But here's the problem. Every major tech company has publicly promised to be 100% carbon-free by 2030. Microsoft, Google, Amazon, Meta, they all made these huge commitments. If they start building more gas plants, they look like hypocrites. Environmental groups freak out. Investors get nervous. Customers start asking uncomfortable questions. So they're stuck. Can't rely on solar and wind alone. Can't use fossil fuels without breaking their promises. The traditional power grid can't expand fast enough. What's left? Nuclear power, but not the kind you're thinking of. The problem with old nuclear. Traditional nuclear power plants work great. They're clean, reliable, produce zero carbon emissions, and can run basically forever. But they have one massive problem. They take forever to build. I'm talking 15 to 20 years from breaking ground to actually turning on. And the costs? Absolutely insane. There's a plant in Georgia. 2 new reactors that were supposed to show how America could build nuclear plants again. They took 15 years and cost $35 billion. That's with everything going relatively well. Think about that. 15 years. In the tech world, that's an eternity. The iPhone didn't even exist 15 years before ChatGPT launched. No tech CEO is going to wait 15 years for a power plant. By the time it's done, AI will have moved through like 5 generations. So they need something faster. Something that doesn't take decades to build. Something that sounds, honestly, kind of like science fiction. The new idea, factory-built reactors. Here's where it gets interesting. What if instead of building a nuclear reactor on site, which takes forever, you built it in a factory? like the same way you build cars or phones. Assembly line, quality control. Repeat the same process over and over. Then you ship the whole thing on trucks or trains, drop it at the data center, connect some wires, and turn it on. That's the basic idea behind small modular reactors and micro reactors. Let me explain the difference. Small modular reactors, SMRs, produce between 50 and 300 megawatts of power. That's enough for a decent-sized city or a large data center complex. Micro reactors are even smaller, 1 to 20 megawatts. These are designed to literally fit inside shipping containers. The tech is pretty wild. Instead of using water to cool the reactor, which requires massive pumps and complicated piping, some of these use helium gas or molten salt. These coolants can handle way higher temperatures without boiling, which makes the whole system simpler. The fuel is different too. Instead of long metal rods, they use tiny ceramic-coated fuel particles. Each one is engineered so that even if something goes catastrophically wrong, the fuel just sits there, holds itself together, doesn't melt down. It's called passive safety, meaning the reactor is designed to shut itself down safely without human intervention. And because everything's built in a factory, you're not reinventing the wheel at every construction site. You build one design, test it, perfect it, then build the same thing over and over. Old nuclear, custom built, 15 years, $35 billion. New nuclear, factory built, 3 to 7 years, $1 to $3 billion. Still expensive, still not exactly fast by tech standards, but way more realistic for companies that need power by 2030. Who's actually doing this? This isn't just talk. Big tech companies are already signing contracts and writing checks. Amazon dropped $500 million in late 2024 to back a nuclear startup. They're planning to start with 4 small reactors producing 320 megawatts, with plans to scale up to 960 megawatts, almost a full gigawatt dedicated to their data centers. Google signed a deal to get a new reactor online by 2030, producing 50 megawatts at first, but potentially growing to 500 megawatts by the mid-2030s. Microsoft went a completely different route. They're restarting 3 Mile Island. Yeah, that 3 Mile Island, the site of America's worst nuclear accident in 1979. The reactor that melted down is staying shut forever, but there's another reactor right next to it that's perfectly fine. Microsoft signed a 20-year contract to bring it back online by 2027, which will produce 835 megawatts of power. Cost to restart it? About $1.6 billion. Then there's Meta. In December 2024, they sent out a request asking reactor developers to pitch them plans for 1 to 4 gigawatts of nuclear power by the early 2030s. That's enough to power multiple mid-sized cities. Add it all up, and you're looking at tech companies planning to build or restart 26 plus gigawatts of nuclear capacity in the next decade, at about $3 billion per gigawatt. That's pushing toward an $80 billion total investment in pocket nuclear power. That's not a typo. $80 billion. The risks nobody wants to talk about. Now, before you think this is some perfect solution, there are some serious concerns. First, these designs are mostly unproven at scale. Yeah, the theory sounds great. Passive safety, simpler designs, factory built. But we haven't actually run a fleet of these things for years to see what breaks, what goes wrong, what nobody thought of. Second, regulators are relaxing safety rules for these smaller reactors. Things like smaller containment buildings, smaller emergency zones, fewer security staff. Because the reactors are smaller, they're getting looser requirements. Some experts say that's fine, because the designs are inherently safer. Other experts say we're taking shortcuts before we really understand the risks. Third, the timeline is brutal. These projects have to come online by 2028 to 2030 to matter for AI. If they get delayed, and big construction projects always get delayed, then what? The fallback is pretty simple. Burn more natural gas, which defeats the whole point of going carbon-free. Fourth, nuclear waste is still nuclear waste. These reactors produce less waste than traditional ones, and some designs even burn waste from older reactors. But you're still creating radioactive material that has to be stored safely for thousands of years. Nobody's really solved that problem yet. What happens next? So here's where we are in December 2025. AI is exploding. Power demand is skyrocketing. The grid can't keep up. Solar and wind can't provide reliable 24/7 power. Fossil fuels break climate promises. Traditional nuclear takes too long to build. So tech companies are betting $80 billion that they can factory build small reactors, truck them to data centers, plug them in, and have them running by 2030. If it works, nuclear power stops being a massive construction project and becomes a repeatable product. Clean energy at scale. AI keeps growing. Climate targets get met. If it fails, we're back to burning gas, breaking climate promises, and possibly hitting a hard ceiling on how fast AI can grow. There's also a third option nobody wants to talk about. AI slows down. Maybe we don't need ChatGPT to get smarter every 6 months. Maybe we don't need AI generating 1 billion images a day. But nobody in Silicon Valley wants to hear that. Final thoughts. So that's the situation. Tech companies have an electricity problem. Their solution is building nuclear reactors small enough to ship on a truck. It's a massive gamble. $80 billion riding on technology that's mostly never been built at scale before. But if they pull it off, it could change everything. Not just for AI, but for how we think about clean energy. What do you think? Is this brilliant or insane? Drop your thoughts in the comments. I'm really curious to hear what you all think about this. And if you find this interesting, hit that like button and subscribe for more deep dives into the engineering and technology shaping our world. Thanks for watching. See you next time.